Welcome to Study Loop.
Here we have a skydiver, and she's opened her parachute, and the air drag pushing the chute upward is stronger than the Earth's force of gravity pulling her downward. And her friend says this means she should start moving upward, but we know that's not true, so we want to discuss why this isn't so. And so we see that nowhere is her velocity going to be upward. So we have the force of gravity down, and then the drag force up. And we know that the upward net force on Nellie during the short time that the air drag exceeds the force of gravity will produce a momentary upward net force and an upward acceleration. But this produces a decrease in her downward speed, which is still going to be downward because the downward velocity and the force of gravity is so much stronger in this case than the drag force that it will still produce a downward velocity. So the sum of the net forces is still going to be the force of gravity minus the force of drag. And so even if you increase this value, it will still maintain the downward velocity. But you do feel like a jolt when that happens because you've experienced a change in acceleration. That you do have that temporary acceleration upward, but that doesn't mean that your speed changes to be upward. You've just decelerated. So instead of gaining speed falling down, you're now gaining speed at a lower rate because we know that acceleration is just the change in velocity over time, so dv over dt. And that's why you don't ever move upward even though you feel an upward acceleration.